Centroid means mean of the cluster or the group. Midpoint. Centroid means midpoint of the group. Centroid is mean, not median. Centroid for all, it is called K means. It is not K medians. It is K means. So centroid by default means mean, not median. Centroid in statistics means by default mean. So this is both an unsupervised and supervised learning algorithm. It works with dependent variable and also without dependent variable. And it uses Euclidean distance. The distance calculation, there are many, Euclidean, Manhattan, Minkowski, all those distance metrics are used here. You can use any of them. By default in most of the software, I think by default in Python is Minkowski. Minkowski is the default in Python. Euclidean, Minkowski, Canberra, these are all the distance metrics. By default is Minkowski in Python. For text data, we use Hamming distance. For text data, we use Hamming distance. So distance metrics in clustering. So the basic is your Euclidean, then you have Canberra, which is the absolute, and then Minkowski to the power of, and then Chebyshev is maximum of, Euclidean is again this, Manhattan is city block distance absolute. 1 by P, 1 by R or 1 by P? 1 by P, I think. One second. What is the distance? R. 1 by R. R is equal to 1 means Manhattan distance. R is equal to 2 is Euclidean distance. R to infinity is supremum. So either you should give more than 2. The R value, absolute to the R to the power of 1 by R. This is R. 1 by 2 will become Euclidean. 1 becomes Manhattan or city block distance, and R to the infinity. Anything greater than 2 till infinity, you can use it as Minkowski's distance. So it's R. You can see here, right? Clearly, R. So R is equal to 1 means Manhattan. R is equal to 2 means Euclidean. You should give R value more than 2 to get it as Minkowski distance. So these are the popular distance metrics which are used in clustering. Same thing we use in KNN also, right? The only difference is KNN will have a dependent variable. Here it doesn't need a dependent variable. It can work with dependent variable also, but it typically does not need a dependent variable. And it's an iterative algorithm. It's keep on iterates till the cluster formations are no longer can be changed. See, the basic thing is the iterations will stop when there is no change in the cluster formation. As long as the cluster formation changes, the next iteration will be run. Cluster formation means some observations were previously in cluster 2. In the next iteration, some of them have been moved to cluster 1. That means it will redo the whole process again to check. But in the next iteration, if the same thing stays, cluster 1 and cluster 2 as it is, it stays, then it will stop. It iterates till the observations assigned to the cluster do not change. As long as there is no change in the cluster or cluster observations assigned into the cluster, it will run. Once it sees there is no change in cluster alignment or cluster assignment, then it will stop there and it will define it as your final cluster. So that is the thing. So it's an iterative algorithm where everything depends on centroid. It calculates the distance between the centroid and the observations, and based on the minimum, what we call distance, the observations will be assigned to the relevant cluster. Yeah. You will not get, because initial is random assignment. The first assignment is always a random assignment. See, what happens is it randomly selects the observations as centroids in the first iteration. So obviously, when you don't set a seed, random seed, your random and my random will be different. Then there will be a change in the algorithm every time you run it. So the first iteration, the centroids are picked randomly. And what are the centroids? One of the observations in the groups. Centroids are not brought from outside. Centroids will be selected from within the group itself. Okay, and then a random selection will be done, and then the calculations will be, distance calculations will be done, and then the assignments will be done to the relevant cluster. And this whole process is repeated till there is a change in the cluster assignment, or observations are assigned to the cluster changes, then it will continue. Once there is no change, then it will not. Once there is no change, it will stop. The iterations will stop. Now, if you look at the data set which I have given here, there are two independent variables, x1, x2. And let's assume our k is equal to 3. Like I am assuming the k is equal to 3. So that means we are creating 3 clusters. And we are using Euclidean distance. For your computational stage, we are using Euclidean distance. We will use the Euclidean distance, and the k assumption is k is equal to 3. A random assumption of k must be done. Once that is done, we plot the variance on an elbow plot. The point at which there is a bend, from the point that will be your cluster differential, or the point at which the variance is becoming minimal, that will be your k value. Second type of to make sure the clusters are done properly or not, we have to use Silhouette score. The point from which the variance becomes minimum, that will be your k value. After that, the k value does not make any difference. Now, let us say we are assuming k is equal to 3. That means we are going to classify this set of data into 3 clusters. That means we need 3 centroids. Let us say it randomly picked these as centroids. A1 is one centroid. It randomly identified A4 as the second centroid, and then it identified A7 as the third centroid. These are random identifications. It randomly picked A1 as the centroid for cluster 1. It picked A4 as the centroid for cluster 2, and it picked A7 observation as the cluster for centroid 3. Now we will calculate the distance from T1 2, 10. 2, 10. So we have to find the distance between 2, 10 to all other observations. So what is the formula? Is equal to SQRT, open 2 brackets, observation minus 2 to the power, or you can select the same value, fix it by pressing F4 to the power of 2 plus open bracket 10 minus again 10 or you can manually type 10 also, your choice. This is your Euclidean distance formula. Square root of x2 minus x1 whole square plus y2 minus y1 whole square. Here x2 is 2, y2 is 10. So obviously first distance will be 0. Now if you double click this, if you scroll, take the formula down, you can see the distance calculated for all the other observations. We will make them equivalent to 2 decimals. We will make them equivalent to 2 decimals. So centroids have to be fixed by pressing F4, or in some laptops it is Fn plus F4. In some laptops it is Fn plus F4. Okay, all of you got this? All right. So similarly, we have to calculate distance from cluster 2. What are the cluster 2? 5, 8. Cluster 2 is 5, 8. So is equal to SQRT, open 2 brackets, 2 minus 5, fix the 5 by pressing F4, to the power of 2 plus, open bracket, 10 minus 8, fix the cell, to the power of 2, close bracket. For cluster 2, the points are 5 and 8. Okay. So 3.60 to drag the formula down to decimal. Similarly, distance from cluster 3, 1, 2 is equal to SQRT, open 2 brackets, 2 minus 1 Fn plus F4 to the power of 2 plus open bracket 10 minus 2 fix it by pressing F4 to the power of 2 close bracket. Then we drag the formula down to decimal. Okay, all of you have calculated the distance. All right, all of you have got this. Now, what is the minimum distance among these three? 0. So the cluster assigned would be C1. The minimum distance among these three, 3.16. So the cluster assigned would be C3. Minimum is C2. Minimum again is C2. Here minimum again is C2. Minimum again is C2. Here it is C3. And here again it is C2. So this is the first cluster assignment done by based on the Euclidean distance calculation. Based on the Euclidean distance calculation, it has done the cluster assignment. Minimum of these three, whatever is the minimum, that will be the cluster assignment. Minimum of the three distances. All right. Then it will start iteration 2 to check whether the cluster assignment stays as it is or will there be a change. Copy the data points down. Now, the centroids, initial centroids were picked up randomly. The initial centroids were picked up randomly. Now, the clusters are assigned, so no need of random picking. We can find out the centroid for cluster 1. So, what are the observations in cluster 1? This. Then only one observation is there in cluster 1, that is 2, 10. The cluster distance for the centroid for cluster 1 is 2, 10. Similarly, for cluster 2. Now, for cluster 2, we have many observations. So, 1, 2, 3, 4, and the last one, 5. So, if you see in the bottom, there is average. 6. You can see here, right? Average. So, 6 is the new centroid, comma. Let us select the second values, 1, 2, 3, 4, and then the fifth one. Again, average is 6. So, distance for this is 6. Just for cluster 3, the centroids would be, there are 2 cluster 3s, right? 2 and then 1. So 1.5, one centroid, and then 5 and 2, 3.5. So 3.5 is the centroid for cluster 3. is the distance for the cluster 3. Now we have to calculate the distance again. Is equal to SQRT open 2 brackets. Now we have to use manual way because the centroids are calculated separately. 2 minus 2 to the power of 2 plus open bracket 10 minus 10 to the power of 2 close bracket. Now you can write the formula till 8 and reduce the decimal to 2. No difference in the cluster, but this will be different. Is equal to SQRT 2 minus 6 to the power of 2 plus 10 minus 6 to the power of 2. 2 minus 6 to the power of 2, 10 minus 6 to the power of 2. Similarly, is equal to SQRT, open two brackets, 2 minus 1.5 to the power of 2 plus open bracket 10 minus 3.5 to the power of 2 close bracket. Centroid fixing based on the clusters. So C2 are these clusters. So you take the C2, 1, 2, 3, 4, and the fifth one is this, 1, 2, 3, 4, and then the fifth one. You can see the average here. Average. Control and last control and the last cell you have to select. Control plus last cell. Keep them selected and then press control and then select the cell. It will select. Shift plus select those cells, then control plus select the last cell. Put it down now, that way you don't need to switch on the start again. Put it down completely. What there is the average of the cluster values. If you have any doubt, copy and paste them into separate place. Now, why you are getting confused? So these are the C2 values. Randomly, now you have taken them as randomly. That's what I told you. Randomly choosing those three values. First iteration it is random selection. Second iteration is calculation of centroids. Your choice. It is random selection. First iteration is always random selection. I have clearly told you. Second iteration is calculation. First iteration is random selection. Second iteration is calculation. So second iteration, we calculate the centroids based on the previous iteration. Okay. Now reassign the clusters. The minimum of first one is C1, C3, C2, 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 C3, and we have a change, C1. That means it has to restart the iteration process again. Because there is a change in cluster C1. So we have to restart the calculation one more time. So what we have to do is copy the iterations down. Copy the data points. Control C, give a row gap. So iteration 3. Okay. Now we have to calculate this for C1. So C1 there is 2 now, right? 2 and 4. 3, 9.5. So 3, 9.5. 3, 9.5. For the second cluster, I think there is no change, right? Last iteration has changed, right? So we have to recalculate. Okay, these are the values. 6.5 and 5.25. Cluster 3 same. Cluster 3 same, no change. Now we'll calculate the distance again. SQRT, open 2 brackets, 2 minus 3 to the power of 2 plus 10 minus 9.5 to the power of 2 close bracket. Is equal to SQRT 2 brackets 2 minus 6.5 to the power of 2 plus what is the other 5.25 minus 5.25 to the power of 2 close bracket. Drag the formula down. 2 is equal to SQRT open 2 brackets 2 minus 1.5 to the power of 2 plus open bracket 10 minus 3.5 to the power of 2. Why there is change in cluster assignment? C1, C3, C2, C1. Okay, one more change. C2, C2, So we have a change in C1. Here we have a change. Four. So distance from C1. So C1s are 1, 2, 3, 3.67. 0.67, 1, 2, 3, 9, right? Is there any change in C2? Yeah, there is change. There is C2, 1, 2, 3, 7, 1, 2, 3, 4.33. C3, there is no change, right? So is equal to SQRT open two brackets 2 minus 3.7 to the power of 2 plus open bracket 10 10 minus 9 to the power of 2 close bracket. If it is same means there is the final. There is no further change. So this is the final allocation. S2RT 2 minus 7 to the power of 2 plus 10 minus 4.33, right? So cluster assigned C1, C3, C2, 1, C2, C3, and C. So this is the final allocation of clusters. After this, there is no change, so the algorithm will stop here. This is the final assignment of the cluster. What score? Silhouette score, huh? Yeah. Hey, calculating silhouette score in Excel, the formula is slightly. Hey, we calculate that in Python, where the formula is calculated, sorry, complicated. రామకృష్ణ సారీ నేను చూస్తున్నాను అది పంపిస్తాను ఒక హాఫ్ అన్ అవర్ ఓకేనా. హలో 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 గుడ్ మార్నింగ్ రామకృష్ణ చూస్తున్నాను ఒక హాఫ్ అన్ అవర్ పంపిస్తాను. The load score calculation is not there in Excel. You can calculate variance, sum square error. Okay, all of you got the K-means classified? So the only difference is here we have used Euclidean, whereas Python uses Minkowski. So if you look at SQL and Python, default clusters is 8. The algorithm uses is full Elkin variation auto. Solved using Lloyd's Elkin algorithms. They've changed it. Huh? Not Minkowski, Elkin's algorithm they're using. Lloyd's Elkin algorithm. Lloyd's algorithm we call it. Elkin's algorithm. The formula is O into n to the power of k plus 2 by p, with n is equal to n samples, p is equal to n features. Here is the one. research paper they have given. So they changed it in the 0.88. Okay. So we'll pause here. Import numpy renting, import matplotlib or pyplot as plt. There is matplotlib line. Import %cd. Property is security. Air traffic equal to series of double quotes so this is a San Francisco air traffic dot share 18,885 observations, 12 variables. Passenger count is also there. San Francisco airport traffic, passenger traffic. By airlines. All of you imported. I want you to do some exploratory data analysis, generate some questions. Important ones. See, in these variables, what are the critical variables? First one is operating airline. Operating airline is very important, right? Second would be geo region or geo summary. Geo region, whether the flights coming from US or Canada or where they are coming from. We got to change. Geographical region. Then see price category, low fare or other. So let us look at the operating airline first. So find out how many operating airlines are there. You have to identify the critical variables. So First is operating airlines. How will you find out? Air traffic dot group by. Group by what? The column name is airline. Oh, sorry, why am I using group by? That alphabetical stage column. Air traffic dot operating. Oh, square brackets, single quote, because there is a space. Operating airline dot value underscore counts. రామకృష్ణ పంపించాను కదా బి కూడా ఉందా ఒక పంపిస్తాను ఇది చూసి So you can see here lot of small airlines are also there. 89 are there total. There are 89, but the one which are most important value counts. Truncate is there, value counts. Find out how to put all the small airlines into others. Value counts, normalize, sort, ascending, bins, none, drop, and name. Very good. Oh, United Airlines 30701 to 013 is there. United Airlines posts that. SkyWest, Alaska, Virgin America. Then we have a lot of smaller airlines, right? These smaller airlines, how will we convert them into others? Beyond top end. I think there was a simplest command actually. So how do we do that? Type conversion cheyali. Greater than. So what was the lowest number? How do you get the whole output? Dot. At the 60, okay, then make it at 90. రావట్లేదు కదా ఎందుకంటే నాకు 89 ఉన్నాయి 70 could route it, huh? So 60 is what? So shall we take anything above 40 or 50? 40 would be better, right? 40 is better, right? Huh? Less than 40. అప్పుడు ఎన్ని అవుతాయి? Okay. Then that is acceptable. 40 is okay. So convert to others. We have a simple command. Let us try this. No. So let us say aircraft in this value counts as one condition. Is equal to operating dot value counts దీని ఒక వేరియబుల్ కింద స్టోర్ చేయలేము మనము. సో it generated false true boolean వచ్చింది. Okay, df dot where is there? We'll use df dot where. So air traffic square bracket operating airline, right? Where air traffic square bracket operating airline dot value underscore counts less than equal to 40 others. Place is equal to true. Let me see if it works. Let us do the value points again. But still it is coming. Okay, we have to change the index. IDX max. We have to change the categorization into others, right? So what should I do? One second. Data corrupt available. Okay. Now what should I type? Mask is equal to square bracket single quote operating airline dot map of air traffic square bracket single quote operating airline. One second. Dot value counts. Value underscore counts null brackets. Beta. Greater than 40. Sorry, less than 40. Both brackets outside are like the less than 40. Map or mask ID? Map kada. Rendu mask na? Air traffic. LOC. Other. We are duplicating it multiple times. So four 27. This one, right? So it's very lengthy. But anyway, now import C bond as SNS. For loop is here, it is here. Then it's okay. Then we'll go with this one. Done. Type it in straight line. Mask, is it correct? Mask, comma, other. There might be other. I'll check 1 second. Hey, you can do count plot. PLT dot figure. Fixed size is equal to 15, 15. SNS dot count plot. X is equal to operating airline, comma, data is equal to air traffic. So PLT dot xTix rotation is equal to 90. PLT dot so you can see the things. Functions are all smaller. In Python and R, all functions are smaller. Lowercase. Case sensitive. Which airline? I think United is the largest. United is the largest airline in US. United, Delta, American. Stand about right, start for check it if you want to stand below. Airline by price tag. We have two categorical variable in here. Price tag. T1 standard plot. STACK. Standard bar plot. C bond. Standard bar plot. STACK. Stack. Actually, normal మనం చేయొచ్చు. Categories define చేయండి. Start the bar plot. ఇప్పుడు మనకి లో ప్రైస్ హై ప్రైస్ ఉంది కదా, మనం యాక్చువల్గా సీబాన్ అవసరం లేదు. PD డాట్ crosstab air traffic square bracket single quote operating airline comma air traffic dot the variable name is price category code. So airlines and price category code we got. Low fare or other. దీన్ని మనం చేయాలి, ప్లాట్ చేయాలి. సో మనం ఏం చేయొచ్చు అంటే ఎయిర్ ట్రాఫిక్ డబుల్ స్క్వేర్ బ్రాకెట్ సింగిల్ కోడ్ ఆపరేటింగ్ ఎయిర్లైన్ comma single code price category code dot plot kind is equal to bar. Oh, got an error. No numeric data to plot. Okay. So we have to do for SNS dot set underscore index. Index is operating guideline. Sorry. Dot plot kind is equal to var comma stack is equal to true. What happened? No numeric data to plot. Yeah. క్రాస్ ట్యాబే చేయాలి మనం అప్పుడు. ఇది ఉంది కదా pd డాట్ క్రాస్ ట్యాబ్, దీన్ని డాట్ ప్లాట్ kind is equal to var comma stack is equal to so we got the A line wise this one. We have to increase the size. PLD dot figure fixed size 15 by 15 చేసి yeah, why it is not going here? PLD dot figure. Figure size is not expanding here. How will expand? Fourteen forty into 1440 axis. This is the plot we want it in SNS. C bar. Cross type is working. Okay, let's go more ahead. All right. Now let us start Let us create a scatter plot. Airline underscore count is equal to air traffic square bracket single quote operating airline dot value underscore counts. We'll sort the index also. Airline underscore count dot sort underscore index in place is equal to true. Passenger underscore count is equal to air traffic square bracket single quote passenger count dot group by air traffic square bracket single quote operating airline dot sum. Passenger underscore count dot sort underscore index in place is equal to 2. Yeah. Spelling mistake. Check again spelling mistake. Not found means you have made a spelling mistake. It's just PLT code, that's all. If you don't want the cluster names, you don't need to write it for loop. You can simply do the scatter plot. But you need to understand what is the outlier, USA planes or something. Hue అంటే కలర్ కోడ్. హ్యూ అంటే కలర్ షేడింగ్. Outliers are United Elements. Okay, all of you got the scatter plot? In Unsupervised, there is spelling mistake again. Check your spellings. Go down the error, it will point to the point, with the error will point where you got the error. There will be error points to the error line. That you have to correct. And then you can use the square brackets. So there are two square brackets. Xi and yi in one square bracket and out square bracket. Xi and yi should be in one bracket, one parenthesis. This you listen. It is pointing to that only. Got the graph? Scatter plot? The thing is, if you don't want the names, you can just plot it, PLT dot scatter. But if you want the name, the dots, then you write the for loop. Otherwise, if you don't want to write the names of the dots, you can just simply plot. So what dot belongs to what? If you want to understand, then you have to write the names. Done? All of you done till this point? Scatter plot. Now we will build the k-means. From sklearn dot cluster import k-means. X is equal to np dot array list z x comma y. We are grading our x. Now, like I told you, we don't know what is the value of k here. We exactly don't know what is the value of k here. So we will take a range of values of k from 2 to 10. And then we will see which is our best forming k, and we will build a model with that k value. Inertias is equal to null braces. Inertias means no change for k in range of 2, 10 column. So we are giving k is equal to 2 till k is equal to 10. It will do iterations, multiple iterations. K means is equal to k means n underscore clusters is equal to k. K means dot fit x inertias dot append k means dot inertia plt dot plot range 2, 10, inertias O hyphen G plt dot x label cluster plt dot y label inertia plt dot show. Oh, we got an error. Okay, no issues. Right. It is pointing to inertias. Inertia means no change, constant variance or low variance. What are we getting? Where are we getting the error? PLT plot, it is giving an error. Acha, 2,10, yeah. Shit. I gave 2,20. Okay. Yeah, I gave 2,20. It is 2,10. 3 or 4. After 4, it is becoming straight line, right? This is the point at which it's becoming a straight line. So 4 is the point. Or you can take elbow. This is the variance is there, no? Significant variance is there. So 3 or 4, based on the Silhouette score, we have to take. Now, when you have these 2 points, now you have to do Silhouette score. We'll build a model with 3 and then calculate the Silhouette score, and we also do a model with 4 and do the Silhouette score. Which are 4 only, it should be more. 4 only should be more. So the change as the, I think you can also give dots. O-G will give us the dots. So 4 looks better, right? 4 looks a better option. Okay, you want me to go up? Okay. Okay. Now we have let us build a model. What are you getting? X, you have created np.array list zip x comma y. You might have forgotten to do this. np.array list zip x comma y. So k means underscore 4 is equal to k means n underscore clusters is equal to 4, right? K means underscore 4 underscore model is equal to k means underscore 4 dot fit x. K means underscore 4 model dot core x. Dot close, we have lot of algorithm cluster centers, labels, clusters. Cluster centers we can see. So these are the cluster centers for the 4 clusters. np dot round comma మైనస్ లో వచ్చింది ఓకే అది వేరియన్స్ అది వదిలేండి క్లస్టర్ సెంట్రాయిడ్స్ మనకు కావాలి కదా ఈ ప్లస్ లో వచ్చింది np.round is not working here. Why it is not working? Okay, so let us predict. K means underscore 4 underscore predict is equal to K means underscore model underscore dot predict of x. From sklearn dot metrics import Silhouette score. Silhouette score x comma k means underscore 4 underscore prediction 79. So the clusters are very clear. 4 is the better option. ఏది అది అవ్వలేదు కదా, నేను తీస్తాను. అది ఇట్ వాస్ నాట్ చేంజింగ్ ఇట్ టు నెంబర్స్. Why it is not changing? Normal గా రావాలి, ఇవన్నీ ఈ ప్లస్ లో ఉన్నాయి. సో let's go closer to 1. Then 3 would be the better option. So we did the scatter plot with the clusters. That's not 4 and 3, not much of a difference. అది మొత్తం బ్లూ వచ్చింటుంది. కానీ ఇప్పుడు మనకి సెపరేషన్ ఉంది, అక్కడ సెపరేషన్ ఉంది కదా క్లస్టర్. ఇక్కడ చూస్తే మీరు there is a separation of cluster there. ఓవర్లాప్ లేదు, రెడ్ అండ్ బ్లూ. So 4 is better. There is no nearness, there is no overlap. So 4 is better. Cluster formation కూడా చూడాలి కదా. We can't go with only one thing. You have to decide manually which is the best formation. Circular purposes study, but they are showing some distinctness. There is some sort of distinctness being shown, right? And particularly this one, which is showing far off. So blue will extend, the variance in blue will be very high. If you take the variance of this blue, this will be very high if you include red. If you do not include red and keep red as a separate category, the variance in blue is less. Red also will have a slightly higher variance, but okay, to some extent. So PLC dot scatter K means 4 model dot cluster centers. Colon, comma. Colon, comma 1, comma thing, colon, comma. These are the centroids. These are the centroids. But centroids are not good. So we will not put centroids. We are getting 2 centroids, but it should be only 1 centroid. Okay, we have 2 variables, no? So we are getting 2 centroids. Okay, this is the K-means clustering. Okay, so if you're done, if you don't have any doubts, we'll stop it here.